Okay, so everyone in this room, if you are a developer, should know Git, how to use Git in proper way, because it doesn't matter if you are working with .NET, Node.js, or C++, or just writing some automation scripts in PowerShell, or working on Windows, Linux, or macOS. Git works perfectly with all platforms, and maybe that's the reason why it's so popular these days, and that's also the reason why I created this talk. So to begin, I would like to show you some graph of source control, or more like version control systems popularity. It's just from Google Trends, so it's not like how many Git repositories are there, because it's quite hard to find out. But definitely Git is currently the most popular one, and you can see that it's basically the reversed graph of Subversion. So Subversion was here in 2008. It was basically the main development tool for source control, but since then Git is having quite a lot of users. And if you, for example, look at what Microsoft do right now, you can find out that, for example, new .NET Core platform and a lot of their tools and libraries, even for older .NET, is hosted on GitHub, using Git as ideal platform for collaboration on a code, and not just with the community, but also in internal teams. Also here in Actum and in most of the companies, the Git is used quite widely. So I think that's ideal time to just refresh your knowledge of Git, and maybe dig a little bit deeper in some features to be sure we fully understand how Git works, and it can give us quite nice basics for using it even for complex scenarios. Okay, so in the first part of presentation, I will just begin with some Git fundamental basics, and then we will go through some basic commands we are using in the Git. I will try to explain what it does internally, and in the second part, I will dig deeper into how synchronization with remote repositories works, and at the end of presentation, if anybody here will left, if there will be any more listeners here, I will try to dig deep into how Git works internally, because Git is designed internally quite nicely. It's quite easy to understand how it works, and it gives us some insights. For example, why some commands are fast, and how, for example, Git do merges, and how it works with switching branches and other features. So in the beginning, I would like to define what is Git. Some general definition is that's cross-platform open source distributed version control system. Cross-platform is pretty clear. It works on almost every platform you are working with, which is quite nice, because, for example, you can use same version control system for .NET development, and also for versioning some configuration files on Linux. So that makes a lot of things easier, and you can learn just one tool. It's open source, and as I already said, it's not extremely easy to implement, but there are a lot of implementations of Git. For example, Microsoft got own implementation for Visual Studio. There is, of course, different types of tools you can use, and everything works with this Git format, with this repository format. So it's quite nice that you can use different tools over a single repository. It's distributed, which is something we will discuss very soon, and I would like to to highlight one thing. It's a version control system. You can also find out that a lot of tooling like Subversion, they call it source code versioning system. This is just some version control system, so you probably will use it on development. But you can also use it, for example, for versioning some of your wikis and things like that. So it's not just for development. It's basically based on idea building some versioned file system tool. It was initially created in 2005 by Linus Torvalds because he needs some tool to collaborate on Linux kernel development, and since then it was like for about 4 years it was it take to prepare tooling for other systems and to basically prove that Git is quite a nice tool for using also on other types of projects. And since then the popularity raises each year. Currently there are quite a lot of version control systems. You can split them to centralized and distributed ones. For example, centralized was Subversion or Team Foundation server source control, or if you've got some clear case or so safe, that's something we would probably like to forget, but it was there and it's still in use on some projects. Also, you can use some distributed systems. There was two major systems, Git and Mercurial, and Git is more like low-level system. But currently it looks like that Git is basically took over Mercurial and is used much more than Mercurial. So Git basically win this race about best distributed system, at least in terms of how much is it used in real world. Okay. So centralized version control system works in quite regular client-server scenario, because basically you need to install somewhere the server. Server contains the repository, and then clients work with the server. And on each client you got a working tree, which is basically the representation of files from the source control, and then you are creating some changes, committing changes to the server, and fetching latest changes from the server. This is something that works for quite a long time, and for example, Team Foundation server works like this, but if you don't have access to the server, for example, connection is down, VPN is down, then some of these systems got some options how you can work in some semi-offline mode, which is quite nice, but it's still some kind of hack how to work temporarily without the server. It's not very clear how it works. It just tries to synchronize changes after you can re-establish connection, but basically these systems are built on premise that the server is available when you are developing. This can be okay for a lot of cases, but for example, if we are working on some client project and the client got their own server, we need a lot of VPNs to get to their source control. Their source control server can, for example, crash, do some maintenance, and it can be quite complicated for us in some cases, and that's also the reason why a distributed system can be beneficial for us. If we compare it to the distributed version control system, it basically it's not necessary to have any server, because you've got the whole repository or part of the repository you need stored locally, and basically every commit and work with commits happens locally, and then you can synchronize commits to another server, to another developer, and that makes it quite flexible for a lot of users. In most cases, it will be some standard scenario that you've got one server with a repository that every developer push all his changes. But for example, if we are working with a client, there can be also another Git repository in client infrastructure, and we can synchronize this client infrastructure just when we need it. But we can work without connection, without online connection to the client. And also we can collaborate on code and, for example, somehow do refactoring before we will synchronize changes to the client, so we can have a little more control over how we are working. And from my experience, there is quite a lot of scenarios where this makes perfect sense, because, for example, you can have some internal development team and there's some other development teams that just got their own repository server, and it's for example, based on setting permissions to these repositories, you can control how different teams work together, even if they are not working in the same infrastructure. So related to software you can use, of course, the first thing you should install is some command line tooling. You can install it on all platforms. It enables you to work with the Git from the command line, and that's preferred by a lot of developers. But of course, if you are, for example, using Visual Studio, there is integration since Visual Studio 2015 you can use, and there are also developers who don't use these command line tools at all, and they are using just the user interface in Visual Studio to work with Git. Also, quite a nice thing is that for example, you can create your repository from command line, and then you can use it from the Visual Studio. The format of the repository is same, so you can use any tool on the one single repository in your operation system. You can combine the tools based on what you want to do. So for example, you can use Visual Studio integration for most of the tasks, but if you need something more advanced, you can use some other tool or command line commands. Another user interface tools are Atlassian source tree. I don't know how much of you are using Atlassian source tree. Quite a lot of hands. And Tortoise Git. Some of you use Tortoise Git. Also a few hands. I know that a lot of people hate Tortoise Git. I quite like it because it's quite close to the real commands you are invoking from the command line. So, but a lot of people prefer source tree, but in general it doesn't matter which tool you will be using. Okay, so what are the main features of the Git? It's fast, it's flexible, and it offers you low-level commands. That's also the two big reasons why to switch to Git. In some cases, because you can work with large repositories quite fastly. You can do a lot of workflows with a Git. For example, for deployment, doing hotfixes and things like that. And for example, the branching with Git is quite fast, quite easy. So that's really something that helps a lot of projects. And also, these low-level commands can be sometimes something that, for example, users of Subversion don't like, or TFS, because you need to know much more about how it works inside. Because if you are, for example, doing a commit in TFS, it's quite simple. It's just one step. In Git, it's a few different steps you need to do, and it can be hard to understand in the beginning, but the level of control you've got with these steps is quite beneficial, and a lot of developers, after a few months of using Git, don't want to go back on the simpler variant, for example, on TFS or Subversion. Another thing is that Git was originally created as a framework for source version control systems, but later they find out that they can build a fully version control system based on Git, and I know there are some small project that used Git as basically the database and version control system, but most of the developers just use Git as it is because it's good enough. So they moved from the idea of having just framework that other developers will build some version control systems over it to having Git as full-featured version control. Also related to the framework thing, there are a lot of commands that you can get really low level in the Git. So, for example, if you are building some tools or you want to do some advanced recovery, you can use the low level commands that's not often used in the regular work, but it's there and you can use it. Another thing is that it's designed primarily as command line interface tool, but as I already said, there are a lot of graphical tools you can use. So it works quite a good in both ways. If you have ever worked, for example, with DFS, then if you, for example, created some repository, link to some remote repository, then it's somehow defined in some weird XML files hidden in your user profile folder, and it's little bit not very friendly to use. Quite nice thing about Git is that basically Git repository is defined by .git folder. If there is .git folder, it means that's the root folder of your Git repository, and everything is there. It's not like it's linked somewhere to Windows registers or something like that. Basically, if you take the folder and move it to your flash drive and restore it on another computer, it's still same repository with everything in it because you move it also with the Git folder. Also, you can just, for example, create copy of your repository folder, and you've got a perfect copy of your repository. So you can, for example, try some functions, try to do something, and if you just screw up, you can just delete the folder and use the copy, and you can continue with the work. So that's quite nice to work this way, because you don't need to just somehow link it and bind it to, for example, Visual Studio or something like that. That was quite messy sometimes. Okay, so I will start with a really simple demo. I will just show how to use few of the tools. So I've got here some empty folder, and I will call Git init. Empty Git repository was created. You can see that in the folder there is the Git folder that contains some of the repository definition stuff. I will go to it how it works later in the last part. And since the folder is there, you can use it from Visual Studio. You can use it, for example, from this Tortoise Git tooling, and I can, for example, show you that I can already start using some comments because the repository is there, but there are no commits right now, so it's just really empty repository. If I just delete the folder, it's just not here anymore, and you can just create the new repository here with a command line or any other tooling. Okay, this gets us to the configuration. So there are three scopes of configuration in Git. There is system, which is the highest scope, where you can define really system-wide configuration. This is used often, for example, on servers, where you can define some common behavior of Git on your server or on your developer machine. There is also the global. Weird thing is that the global is less than the system, because global is global per current user. So that's configuration file that is stored somewhere in your user folder. And there is also the local configuration, which is configuration that is stored in this .git folder in specific repository. So it's configuration really specific to given one single repository. Related to configuration, there are also two files you of course already know, and it's gitignore and git attributes. And gitignore defines which files should be ignored in case you want to stage all changes in your working folder, working tree. So for example, you exclude with this gitignore some Visual Studio artifacts, some user settings of Visual Studio and things like that. But Visual Studio will create these two files for you. And there are, for example, on GitHub some repositories where there are a lot of these gitignore and git attributes files for different types of the projects. So in most cases, it's something that someone will set up in the beginning, and it's probably just with, for example, few updates, not edited during under development. There is also Git. Should be Git attributes, not Git attributes. It defines the line ending normalization, which is a way that Git can normalize line ending if you are working, for example, with on one project from Linux and Windows. It will basically change on commit the line ending in the files, for example, to Linux line ending, so you can work on the project from both systems. But for example, if you are using just Windows development, then of course it doesn't make sense to do this. So it really depends on the environment you want to use. Okay, so I will show a little bit of configuration, and I will show you how Visual Studio will prepare these configuration files. So I will start with a git config command, and it shows you the list of all configuration that is set up in the current folder. So for example, you can see that there is user.name and user.email that defines, if I do commit, then it defines basically the author of the given commit. There are other things related, for example, to where is stored my credentials to the servers, or for example, what kind of merging tool is used. So you can change these settings based on the specific repositories or on the specific users. If you want to, in the beginning, you will probably need to set up the name and email. That's most of the tooling will ask you to do on the first commit or during the installation. I will open the Visual Studio 2017. And create new project. I will just create some regular .NET Console application, and you can see that down here there is the create new Git repository checkbox. So if I confirm it, it will do the initialization and preparing these gitignore files and Git attributes related to this type of project. So one thing is that you can see here the little blue logs. So Visual Studio already recognized that this project is in the folder with the .git folder, and we can work with it. We can do commits. We can basically work with branches and everything. So if I take a look in the folder, there is some project files. There is also this .git folder, and there is prepared some gitignore files that defines, for example, that some of the types of the files should be ignored. There are quite a lot of things that covers a lot of types of the projects and things like that. So you will probably need to update some of it, for example, based on type of the project you are using. But it's quite a good starting point. You should definitely not try to write it completely by your own. Okay. Also, related to configuration, there is Team Explorer tab in Visual Studio that gives you access to the Git commands. And for example, you can see here that there is the setting, and there is, for example, this global setting, and you can define some of the common settings like the username and the email. You can do this from all tools you can download. So it doesn't depend on the tooling. It will store to the same Git settings files. So it's globally shared. Okay, so let's talk about how you work with a Git if you want to work on some regular project. Let's have quite standard scenario where we've got one repository server, and then each developer got clone this repository to their local computer and working on local repository. Basically, the first part of this talk will be about just working locally. So creating commits, rebasing, and a lot of features the Git have, and then we will talk about how to synchronize the changes to the remote repositories to other developers. Okay, so first thing is commits. What is commit? Commit is a snapshot of files. Git don't work with the folders. That's, for example, reason why you cannot create empty folder. So if you need to be sure that the folder is created, you need to create some placeholder file inside the folder. But it makes a lot of things easier if you don't have folder, if you are working just with the files. Also, commit contains the time of commit, author, and of course it can contain some digital signature. We are not using it. But it can be there, so you can make sure that this commit is created by someone specific. Also, the commit contains the links to the 0 to n parents. In most cases, it will be one parent. 0 parents is used basically just in the first commit of the repository. You can have few ways how you can have multiple commits without parents, but in regular repositories it's the first initial commit that don't have any parent. But any other commit typically have at least one parent that defines the previous commit. But each commit is really full snapshot of all files that are defined, that are set and committed in the specific commit. Also, there is ID of the commit, which is hash, and that's pretty important because the hash contains all of these things combined together. So if you, for example, would like to change on the commit name of the author, or change one file, or for example change the parent of the commit, then the final hash ID of the commit will change also. This is the main idea how Git do synchronization with the remote servers. So if, for example, there is a commit with some specific hash on the server, then you've got the same hash on your server, on your local repository, then you can be sure that the whole tree under this commit is the same on the client and on the server. Another important thing is that if you are creating new commit, you are basically specifying the parent commit and the files that changed since the last parent commit. And there's mechanism called staging, and that's the way how you can define which files will be updated and added to the commit. So I will just show a little demo about staging and commits. We have created this small console application because currently there is no commit in the repository. It's newly created repository. I will just commit everything. Or maybe it created first commit. Okay, so it already created. Yeah, I can see that Visual Studio created already 2 commits. It's created first commit that added this gitignore and git attributes files, and then in the second commit it added project files. So I already got 2 commits. And the first commit, you can see that there is the column that contains the hash, and basically this first commit don't have any parents, but this second commit got 1 parent, and that this previous commit, and that's the reason why it's linked together. I use this tortoise git show log window because it seems to me that's pretty clear, and you can do a lot of things related to git operations. So I will use it to show everything, but you can also use for example command line to show commits, and also of course Visual Studio provides some tooling. But I already forget where it is. Yeah. Okay. Yeah. To show you exactly the same data. So all of these data are stored in this .git folder, and we will get to how it's stored in the end of the talk. Okay. So currently everything we are doing is just a local repository. When we created the repository, Visual Studio created Git repository, but there is no remote server, no server to synchronize our commit. So everything we are doing right now, working with the commits, it's only done against the local repository, which is exactly the same approach if you are working also with some remote development server, but there is one more step, and this step is synchronization your commits to the remote server and remote commits to your local repository. But we will start just with this simple local changes, local repository. Okay, one thing I can do is, for example, to extend the code. So I will add some awesome code, and currently I can do something called git status. I will just move from one tool to another because it really doesn't matter which one I use, and it gives me one information. It tells me that I'm on master branch, which is default branch, and currently we are working against the last commit that is in this branch, which is also called head commit, and I can see that there is one modified file. This modified file is, if we want to commit it, if we want to create new snapshot that contains the current status of the project also with this file committed to it, I can call command add, and it will move this file to the stage, and the stage is basically the list of files that will be committed. It's a template for a new commit. Some of the tooling will, for example, hide this from you, but this is the way how you can define which changes you want to commit and which changes you want to keep just in the modified state, but don't commit to the new commit you want to create. You can use it also here from Visual Studio. you can see that there is this part changes, which is the changed files, and there is the staged changes. So you can also define which files will be committed, and only the staged file will be committed. There is one little feature in the Visual Studio that even if you unstage change, so it will move back to modified state, you can commit it in Visual Studio, and if you just didn't select any files to the stage, it will just stage all changed files, so you don't need to do this stage phase. So it's something you don't need to worry about if you want to just commit everything. If you are working from command line, I can see that it's back in the modified state. In most cases, you will call something like git at all, and then you can call git commit, and commit has been created. So new commit has been added to this commit tree, and currently, if I check the status, there are no changes. And also, if I refresh this Tortoise Git, I can see there is the third commit that's based on the previous commit, and it contains just one modified file. I can, of course, see that just one line has been added. And that's one level of control you've got, because even if you are not working with the remote repositories yet, you can do commit, and you can check exactly what have you done in this commit, and you can, for example, change it later. You can change it until you distribute it to the remote server. After you send it to the server, then changing commit will create a little bit mess. So just do it until it's pushed to the server, if you need it. That's, for example, one of the features, quite nice features, where I can change the file. And you can do something called amend commit. And if you check amend commit, it's in all tools it's done differently. But here, if you check it, you can update the last commit, and it will basically merge changes you did right now with the changes from the last commit together. So you still got only one commit. Okay. So the commit changed, and also 3 exclamation marks has been added. But as I said, you can do this before pushing it to the server. After you push it to the server, then if you try to amend commit, which means the hash will change, then if you try to push another commit with different hash, it will just create the conflict on the server, and it can be pretty messy. But we will get to it. Okay. Also, because I'm using the Tortoise Git, you can see that there's the first line with all zeros, and this first line represents the changes that is done currently in the working tree. So it's like the first line is the template for a new commit I want to do. Currently it's empty because all changes has been committed. So my working tree is exactly same like this snapshot from this commit 0f815. Blah, blah. Okay, so that's the way how you can create commit. This works great. This is basically everything you need if you want to use Git without branches and just locally. But of course, in most cases, you would like to collaborate with others, or you would like to use branches in your project. So I would like to discuss something called commit pointers, and that's the basic idea how Git works with the branches and how it works with the commits. Branch or tag, it works a little bit differently. In most cases, you will work with branches, but it's basically just a pointer to the commit. So this pointer is some hash that defines the commit to which the branch points to. The branches is a way how the commits are kept alive there is something called garbage collection in the Git, and basically if you've got branch that's pointed to one of the commits, then this commit and all commits in the tree of this commit are kept alive. If you remove this branch, then all of these commits will be lost because no branch is pointing to this commit. You can see it in this log because there is this master tag, which means there is pointer branch master that points to this 0f8 commit. If I create another commit, it will create new commit, and this pointer will be no longer pointing to this commit, but it will point to the new commit, and it will then keep the whole tree under commit alive. If I delete this branch, it will lost all of these 3 commits I already have. There is one more type of the pointer that is called head, and head pointer is basically pointer to the branch, or in most cases it's branch that is currently checkouted to the working tree. So in my case, the current head points to the master branch, and this master branch points to this current commit. The head pointer is there because if I want to create a new commit, it will know the parent of commit I will create. So if I, for example, update this one more time, and I will see change here, and if I create commit, it knows that the new commit parent should be this one. So and of course, because the master is moved to the newest commit, head points to the master. It's basically way how Git knows in which branch you are switched currently. Okay, I will talk about the commit tree, which is basically all commits in your repository that got some branch that keeps it alive. That's quite important because, for example, in Git, if you want to, for example, remove the last commit you created, it's not like the commit is somehow deleted. Just the pointer is moved one commit down, and because the old commit don't have any branches that points to it, it will be collected by garbage collection in Git sooner or later. Also, that's the way how Git works when I did this amend commit, because there was some commit tree, and when I did amend commit, I basically just created the new commit that replaced the old one. But it was still in the commit tree. But in some time it will be deleted. Maybe we can still see it if I just show everything. No, it's not there anymore because it was somehow deleted by Git already. But you can see there branches. For example, if you delete some branch, you can see commits there. Even after the branch is deleted, but commits will be removed sooner or later.
Actually, I think it was not deleted yet. You can show git reflog from the menu, and it will be there. And the garbage collector removes commits after 30 days by default.
Okay. Thanks. So as you heard, it's still there. I think that in the older version of Tortoise Git, these commits has been shown here, but currently it's
there
not.
There is actually another window which would show it.
Really?
Yeah. You need to go to the folder, and there is reflog somewhere.
Okay. Okay, but I know that in the older version you was able to see it in the show log window. But yeah, as you said, the commit is still there. It's just moving with the pointers. So that means that if you want to create, for example, another branch, then it's a really fast operation because you will just create the new pointer, and it will not change anything. For example, in TFS, when you created the new branch, you needed to create the new folder with a copy of the part of the repository, and it was, of course, really slow if the project was large. Right here, you can create as many branches as you want. So I can create as many branches as I just want. And that's the reason why it's so fast. You can just create branch anytime, and it just doesn't do anything with the commit tree. It will just create another pointer. Okay, so right now I will just show some basics of branching. So the thing is that I have, for example, created here the branch 2, and I would like to create some other changes in some different branch. For example, I know that this commit is the version that is deployed on the production servers at client, and I want to do some hotfix on this version. But there are some new commits in the master where are some features that are, for example, not finished and tested yet. So the way you can do this is to have some branch defined on the commit you know there is on the production server, and you can do switch or checkout. Okay, I did a checkout. And you can see that this tortoise git will just make this text larger, and it will make it bold. So it means that this commit is currently checkout to the working tree. Also in Visual Studio, you should be able. It will offers me to reload the file because there has been changes in the older version. There was no the hello world line, and you can see that here. There is the branch 2, and I can switch between the branch 2 and master. Can you tell me what currently happened when I did the checkout of this branch? What operations needs to be done?
The snapshot will be loaded. The old snapshot will be loaded in the tree.
Yeah. And
head pointer will be loaded.
Yeah, exactly. Basically, just the head pointer just moved to the branch 2. There is one thing that is quite interesting. We will get to it in the last part, and that's how the checkout has been done. Because Git knows the changes between different commits, it will just compare the changes between two commits, and it will just update the files that changed between these two commits. And that means that if you are switching between branches, it's really fast operation, or it's fast based on how much files has been changed before these two commits. So even if you've got really huge project and doing switch between branches where only few files has been changes, it will be extremely fast. Okay, so currently if I create some other change, for example, I will add some command here. And I will commit it. Okay, trying to sell me, I guess, Team Foundation service. Yeah, Team service. No, I will not buy it. Okay, so right now the new commit has been created, but the old commit tree has not been affected. Because you can see that old master still got the same parents, only this commit has been used as a parent for both the master commits and branch 2 commits. Also, as I said that you can work with with branches just as a pointers. You can, for example, switch the master and branch to branches. You can do it quite fast if you need it for some reason. Of course, it does not make sense, for example, right now, but you can do it, and it's just moving of pointers. It does not change the hashes of commits. It does not change anything. That's something quite important in the Git because right now this commit is in the branch 2, but it does not mean that, for example, I can create here another branch, another one. I can switch to this, which was extremely fast because I am on the same commit, so it does not need to affect any files, and I can just remove the old branch 2. If I just delete also this another one branch, it will just forget after some time this older commit. But the commit is not assigned to some specific branches. It's just about pointers to the commit. It's not in any way, this commit is not in any way somehow tied to the one specific branch. So for example, if you've got the commits, the development split into 2 branches and it's merged together, you basically cannot recognize which part of the tree was related to which branch. It's just a commit tree.
Tomáš, does it make sense to make several children commits from one parent within one branch?
Can you just repeat the
If I will make several children commits, I mean with one parent. Children means several commits which has one parent.
Mm-hmm.
And these several commits will be within one branch. So will not point one commit should be related to one branch and second commit should be related to second branch. Let's imagine both of them will be related to master. Does it make sense to use this approach somehow?
I'm not exactly sure if I get it how you meant it.
Okay, right now you're on another one branch. Let's say if you will switch back to the parent, which is add project file, and make some changes and make another commit from this step.
Okay, so basically you cannot create these commits until you are in some branch, because it will just create a commit that will be lost immediately. Mm-hmm. You can check out commit that is that don't have branch. That's the one situation where the head is not pointed to the branch but to the specific commit. But then you cannot directly commit. You need to create some branch, because it does not make sense to just create an empty commit, or not empty commit but commit without the branch.
Actually, you can, if you try to do it, it will create another reference which is called detached head, which will be there temporarily until you switch to another branch. I know it's there because the head will point to this commit, but it will create one more temporary branch until you switch to another, and the detached head will be deleted.
Yeah, sure, but it does not make in general sense to do it without the branch. Of course, you can do it. There are mechanisms that, of course, it will not just let you to the commit and then just delete it. It does not make sense, but in general, it's not possible. It will still create the branch to make it possible. Okay, so we are getting to the merging. Merging is done from the branch you will select or the commit you will select to the current head branch or to the current head commit. So it can be maybe a little bit confusing for someone who, for example, works with a TFS or SVN. But if you are doing merges, it's always merged to the current commit, to the current branch you've got in your working tree. And there are basically two reasons why you want to do merging. First reason is you've got two separate development branches and you want to merge it together. And the second one is when you've got some work, for example, from your colleague, you synchronize the changes to your repository and you want to merge your changes and his or her changes together. Of course, in both ways it works exactly the same, but these are, from the usability point of view, two situations where you want to do merging in most cases. Typically, if you are merging two branches, then the new parent, then the new commit is created, but you've got two parents, so it basically merges the commit tree together. There is also a type of the merge that is called fast forward merge. I will show how it works, but it's basically just moving to the pointer. It's in the cases when you don't have another commit in the separate tree. Okay. So I will, for example, created this another one branch, which was some kind of hotfix. I deployed this hotfix to the production, and I want to get back to the regular master branch and continue in development. I can switch back to master branch, and I can do the merge. You can do the merge in with a different tooling. You can click here and just click merge, and you can see that there is merge to master. So you are selecting which branch or which commit will be merged to your current head branch. If you are using command line, you can just call git merge master. Git merge another one, because we are merging to the current one to the master. So I will try to do the merge. It worked. So the merge commit has been created. Merge commit is here, and there are two parents. There is the parent from the branch I merged to it, and of course there was these two commits that was on the in the master branch before. So if I, for example, delete this another one branch, which is something I can do right now, because even this commit is already part of the commit tree of the master branch, and it's just removing one pointer. And right now you basically cannot tell what happens in the past. You just see that there was some split of the commits. There was these two commits on the done probably in one branch, and this commit probably done in the second branch, and there is this merge. But the information about the another one branch or this branch 2 is currently lost, and it doesn't matter anymore. Okay. Another thing you can do, another type of the merge, is this fast forward merge. So I will create, for example, branch 3, and in case I would like to merge this branch to this branch, then the fast forward merge can be done, and it means it will just move the pointer from this commit to this commit, because it does not need to create some merging commit. You can enforce to create merge commit, but for example, right now you can just needs to be done other way. I'm here in the branch tree. There are some new changes in the master, and I want to get these changes from the master to the branch tree. The easiest way how to do it is just to move the branch 3 to this commit. I don't need to create some merge commit, because I don't need it right now. So I will try to do the merge. 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 So I will merge master to it, and I can see that here's the line fast forward, so the fast forward has been used, and just the pointer has been moved to the newest commit, because you don't need to create the merge commit. In some cases you want to create merge commit even if you can do the fast forward, but this is not the case. Okay, so currently, do you have any questions related to the merging?
Once the branch is committed to the master branch, its name is forgotten, or can I filter the branch which is already merged to another one?
Well, you have to look at the branches just as a pointer. So it depends if the branch is still there, and if it's still there, you can just find where the branch is pointing to, and you can find the commit. You can find where the branch is.
Because if I want to look to the history for work of someone, and I know he was working on some thing in some branch, but now the branch is already merged, how can I find his commit?
If the branch has been, for example, already deleted, which is quite usual when you are completing the pull request, then you cannot find that the branch with this specific name was there. You need to just check the names of the commits, and typically there is the merge commit that defines what name of the merge has been merged to the master, for example. You can see that's for example right here in the description message. That's one of the reasons when you, for example, don't want to do the fast forward. It can happen sometimes. Okay. I will move to two more commands that we will need that you can use sometimes, and that's destructive commands. That's reset and rebase. Reset is quite simple command. It will just move your branch to another commit. In most cases, it will just move it to some older commit, and it will just forget the commits that has been done on the given branch. I will just show you how it works. For example, I will just corrupt this solution file. And you can see that because I'm on branch 3, so branch 3 has been moved to the newer commit, and the reset command will just forget this commit and just reset the branch to another commit. There are different types of resetting that can be used for different types of things, but if you use the type of hard reset, it will just forget the commits. So I created to this previous commit, so I can reset it back, and you can see that this commit is there just floating, and if I hit refresh, it will disappear. I can of course reset, for example, branch 3 to this second commit. Do you know what will happen with the commits that's on the top of this older commit after I do this reset?
Will be restarted.
No, they stay there because you still have master branch.
Yeah, exactly. So if I do it, it will just move this one pointer back here, and it will of course update my working tree to this commit. But because there is still master here, it will not discard these commits. Okay, so I will just
So can we say that reset is basically a checkout of some specific commit and deleting all that above?
In this variant, yes. If you are using this reset hard variant, you can use another approaches, which is for example mixed reset, which helps you, for example, to create something like this amend commit that will forget commit but keep your working tree untouched, so you can basically just update the files and do commit again. So there will be different
it's
commits.
like unstage the files, yeah? Check out to specific commit and unstage the files, which will give the